In this video, we'll look at using the quadratic formula to find the intersection of quadratic graphs. Our question is to use the quadratic formula to determine where the graphs of these two quadratic functions intersect, and sketch and label our results. Our functions are f of x equals 2x squared plus 7x plus 2, and g of x equals negative 3x squared plus x plus 3. As a first step, we simply set our functions equal to each other. We need to have our equation in the form ax squared plus bx plus c equals 0. So we'll subtract all the right side terms from both sides. And we end up with 5x squared plus 6x minus 1 equals 0. Notice we did this with a positive leading coefficient 5 for 5x squared. If we had subtracted the other way, we would have had a negative 5x squared. Either way will work. We can now use our quadratic formula. A is 5, b is 6, and c is negative 1. When we put this in the quadratic formula and solve, we end up with negative 3/5 plus or minus the square root of 56 over 10. So our two solutions are x equals negative 3/5 plus the square root of 56 over 10 and negative 3/5 minus the square root of 56 over 10, which, as you can see, are numbers that are not integers or rational numbers. So these are our x values for our points of intersection. We can now evaluate either function at our x values to find the corresponding y values. We'll use f, and when we evaluate f at our two x values, we get our two y value answers. So we have our 2 points of intersections. We can use technology to sketch our graph and label our points. And we can also use completing the squares to find our turning points for these not as pretty functions. For f of x, we factor out the 2, we add in b over 2a squared, and we get f of x equal to 2 times quantity x plus 7 over 4 squared minus 33 over 8. So our turning point for f of x is negative 1.75 and about, negative 4.125. We can also find the turning point for g of x in a similar fashion. We factor out the negative 3. We're careful. Notice when we factor out the negative 3 and we add in 1/6 squared, we're really adding in negative 3 times 1/6 squared. So to balance out adding that in, we add 3 times 1/6 squared. And again, we get our turning point. Now we can resketch our graphs and label our turning point. Notice that the turning point for g of x and that positive x value point of intersection are extremely close and fairly hard to see the difference graphically, so they're both labeled there. We can check our work. We used f of x to find our y values, so if we put our x values for our points of intersection into g of x and compute, we should get the same number, and in both cases that we do. So our answer is our 2 points of intersection are 0.148, 3.08, and negative 1.348, negative 3.8, and our graphs are given.